Matrix. A matrix is nothing but a rectangular arrangement of data, numbers, or maybe functions. Okay, so in the rectangular arrangement, for example, and so here in this slide, you can check. So what is the application of matrix and where are we using the matrices? And you don't have to worry about future applications. In the coming classes itself, you'll understand the application of matrices. For example, we are going to use matrices in three-dimensional geometry to understand the coordinates of an object in a space. Also, we are going to use matrices to simplify a data. For example, if you want to have a multiple dimension for a particular data and it might have more than two axes, we will not be able to represent other than matrix. So with the help of matrix, we can represent the data in a simple way. Okay, so apart from that, there are some examples you can read here. So matrices are used to encode data in the cryptocurrency, so you can check that. Right, so this is one thing. Matrices are used in various interdisciplinary fields such as genetics, yes, economics, sociology, modern psychology, and industrial management. Okay, and also forecasting budgets and forecasting economic activities like inflation, or maybe if there is any uh, even weather forecasting, other spreadsheets programs, we are using matrices. Okay, so as I said, what is matrix? Matrix is nothing but what? Arrangement of numbers or functions or in data in a rectangular form. Okay, in the rectangular array of numbers and functions, right? So that's a quick introduction to matrix. So let's go to the next part. And yes, I hope the question is clear to you. How do we use matrix? For example, if you have, say, if a person has some m number of pens, okay, if a person A has m number of pens and n number of say pencils, okay, and similarly person B has say p number of pens and q number of pencils. Now I want to represent all this information in a simple way. So what I will do, I'll make use of matrix and I'll define my matrix so that it is easy for us to understand how the matrix looks like. So I'm going to use a rectangular matrix with the two rows and two columns here. So as the data is having only this much information, so I'll be having a two rows and two columns. So I will define this is A and this is the B. And in the column, I'm going to represent the number of pens and then pencils. Okay. So now what happens is, so if I write m here and n here, it is very clear that A has m pens and n pencils, and B has p number of pens and q number of pencils. This is one example to understand the use of matrices in representing a data. So it's a rectangular arrangement, right? So what is rectangle? Rectangle has length and breadth. So here we represent the number of rows and number of columns to understand the size of the matrix. Here what do we see? Here two rows are there, two columns are there, right? The size of this matrix, will come to that in the next part. So right now let us see a simple questions on the representation of matrix. Okay, so there is a question here. I hope the question is clear to all of you. Can you please read the question once? So I'll rewrite the question here for your understanding. The question says x into there is a matrix, right, plus y, and it's multiplied with another matrix, so is equal to 4 and 9. Okay, so now we have to find out what is the value of x and y. Okay, so how to find the value of x and y? You will understand this question and you will know this is a very simple question after getting to know more concepts in this. So right now, here what we are doing here is we are actually multiplying the matrix with the variable x and y, and we have two values here. So here it shows two equations. We are simplifying these equations in the form of matrix. One equation is 1x plus 2y is equal to 4. Another equation is 2x plus 5y is equal to 9. So when you solve this equation, you'll be able to find the value of x and y. So how to solve this equation? Obviously, we know simultaneous linear equation method. We can just multiply this equation by 2 and subtract the entire equation. Maybe you can multiply the, let it be first equation, let it be second equation. So when you subtract uh, this equation minus this, we end up with y is equal to 9 minus 8, 1. So when you substitute back here, y is equal to 1, we get x is equal to 2. So what is the value of x? X is equal to 2. And what is the value of y? Y is equal to 1. So this is how we solve. And which option in this case? That's the answer. Option B, x is equal to 2 and y is equal to 1. So there is a matrix here. And how do we represent matrix? So as it is rectangular, before going to this question, let me explain the representation of a matrix. Okay. As I told, a matrix is nothing but rectangular array of numbers or functions, right? So numbers means I can have a random matrix like this, 1, 2, 3, 4, 5, 6. So I can also have a matrix with the functions. So for example, x square, x cube, x. So this is not a number, but these are all functions. So it can be just a number, it can be a function, or it can be a combination of number as well as function. Okay. Now, how to understand and nominate these elements? So the entries we have here, we call them as elements. Okay. Suppose if I am writing a matrix of a random order, I need to understand what element I'm referring. For example, this is the number of rows and this is the number of columns. So you see there are 3 rows in this matrix A and there are 2 columns in the same matrix, right? Now, if I want to take a particular number, instead of telling the actual number, I can even give an address to that particular element. For example, this particular number 1 is in the first row. You can see that it's in the first row and it's in the first column, right? Do you understand? So how to represent this? So I'm going to generalize this matrix in this form: A 1 1. That's the first row, first column. So the subscript indicate the row and the column. So first part, there will be 2 values in the subscript. The first part indicates the number of rows, second part indicates the number of column. So if I simply say Aij, I means the row order, ith row, and j means jth column. So it is 1 1 means first row, first column. So in the first row, if I want to go to second column, I write A12. It goes till A1J because J is the last column. And similarly, I can go for 2 1, 2, 3 1, and I can go till the last row, which is I, if we can represent like this. So the last element will be Aij. What is I here? I is a number which lies between 1, okay, and it can be the highest number of rows, let it be m rows. And what is j? J also lies between starting from 1 because no 0 is allowed here, and it is, if it is a m, the number of rows are m and number of columns are n in a matrix. So generalizing this, j lies between 1 to n and I lies between 1 to m, and very important, I and j are nothing but natural numbers. Specifically, they are natural numbers. They are not negative because it's the order, the position. Position cannot be negative. Also, they are not going to be decimals. They are whole numbers, not just whole numbers, they are natural numbers. Even 0 is not allowed, right? So that means, can you tell me now in this particular matrix A, what is second? Yeah, 2 2. A22, that is second row and second column, which is 4 here. So it's easy to understand, right? Similarly, if I want in the third row, first element A31, which is actually 5. So this is how we give the address or location of an element of a matrix. I hope you understand this, right? So only if you understand, you can solve this question, right? That's why I'm explaining this. I can make a quick note of it or take a screenshot of it quickly so that I can erase this. You can tell me if you're done. Yes, no. Okay. So let me erase this. Let's go to the question now. So there is a matrix. I'll rewrite the matrix here. 1, 3, 13, 9, 2, 6, 4, 5, and -7. So which are the following elements A, I, J generally which satisfy I is equal to J? So I has to be equal to J. So if I has to be equal to J, there are 3 possibilities here because the number of rows are 2, number of columns are also, so number of rows are 3, number of columns are also 3. So there will be 3 possibilities. So A11, that is 1, A22, that is 2, and A33, which is -7. So these elements are here. Okay, what are these elements called? We'll come to that, but generally they are called diagonal elements of a matrix. Okay, diagonal elements of a matrix. So whenever I is equal to J, that element becomes a diagonal element of a matrix. The number of rows should be equal to number of column. So on that basis, which is the answer for us? Our answer is option C, 1, 2, and 7. Okay, so let's go for let's view the answer in that case. So here we are comparing two matrices. I'll rewrite the question again quickly. If this is the one element 4 and then A plus B, this matrix is equal to 8D06. Then what is the question? We have to find the sum of A plus B plus C plus D. So whenever two matrices are equal, so what do we understand is each and every corresponding element should be equal and the size of the matrix should be same. Say the number of rows here, there are 2 rows and 2 columns. Here also 2 rows and 2 columns. Then only I can see the equality between the two matrices. Okay, point 1, very important point to remember. So as we're equating these two matrices, the number of rows in the column should be equal to each other, right? So on that basis, I can equate the corresponding elements. So on that basis, I can say here, so this matrix AB will be exactly equal to 8 here, and D will be exactly equal to 4. And what I see is A plus B is equal to 0. That means one of them is negative of the other. And C plus 6 is equal to 0. Then C is equal to -6. And what do we have here is, yeah, so A plus B is equal to 6. So we just directly take this as 6 and C as -6. Okay, and what is the value of D? We have got D as 4. So what if we add all of them? What we get here is 6 and -6 gets cancelled. The answer is 4, right? So answer to this question is simply 4. So whenever two matrices are equal, what we do? We equate the corresponding elements, and yes, this is how they're equal. Okay, each and every element is being equated, and we are ending up with 4 as the answer here, right? Yes, Mamta, got it? Yeah. So let's go to the next part. We have 3 more questions to solve. So these questions are very important. When you solve these questions, you understand the basic things, like we are now understood when we are equating two matrices, the number of rows and columns should be equal. And when you compare or equate two matrices, you're going to equate each and every corresponding element with the other one, right? So if I have one more matrix, even that should be having 2 rows and 2 columns, then only I can equate it, right? Yes. Let's go to the fourth question here. Yes. Can you tell me now what is this Aij represents? What is this Aij represents? Anyone? Just now we discussed. What does this represent? Aij. Of 3 cross 3. I will come to this later. What is this 3 cross 3? But tell me what is Aij? Aij is nothing but what? Address of the element. Okay. So they are defining that as 1 by 2 times. It is minus 2i plus j. Okay. So in that case, what is A33? That's a question. So we have to find out A33, and in the place of I we have 3, in the place of j we have 3, and our rule for this address is minus 2 times 3 plus 3. So when we solve this, what we get is we get 1 by 2 times, this is 6, this is 3, so we end up with minus 3 by 2. So the particular element we are talking about in the third row and third column should be equal to minus 3 by 2. See, by giving this kind of rule and giving the limit of I and j, I don't even have to write the matrices. I can just give a rule like this, and whichever the element we need or whichever the entry we need, we can use this formula which is defined for the matrix to get that particular element. That means without even writing the matrix, by giving these subscription values and giving the rule for I and j, I can show any big matrix without even writing them, right? So that is one of the another matrix itself is simplifying the data, and even that matrix can be simplified with the rules like this. Okay. Yes. So let's go to the next one. Let's go to the next question. Yes. Any questions? Any doubts? If you have any doubts, obviously you can ask me in the chat box. I'll be responding immediately. So if you don't have time, I'll come back to your question at the end. Okay. So here is the question. There is a matrix. So which is having how many rows here? Can you tell me how many rows are there for this matrix? Number of rows, please. Quickly, how much? 4 rows. Yes. How many columns? How many columns we have here? 3 columns, right? And we have to find A42. That is A42. We don't say 42. A, that is the element on the 4th row and the 2nd column. Can anyone guess what is the answer? 4th row, row 1, row 2, row 3, row 4. We are in the 4th row. And column 1, column 2. So remember, always the first one is a row and the second one is a column. So we cannot reverse it because it's universally accepted and we have to follow which is accepted universally. We cannot redefine it. It is always the first one. First entry stands for row, generally I, and second element stands for column, which is generally j. So 4th row, we want to find 4th row and 3rd column. So 4th row, in this question it is 4th row and 2nd column, so which is 8. Even though there are 4 rows and 3 columns, our question is about A42, that is 4th row, 2nd column. So option C is the answer for this question.